Okay. Are you all able to see my screen and hear me well?
Yes.
Okay. All right. So as Professor Indumati said, this is an awareness training for the participants of the Carbon Zero Challenge who are about to appear for their interviews. And this is an awareness training on sustainability metrics and policy. The goal here is to create the awareness and sort of introduce certain concepts and terminologies so that the participants, the various teams who are already innovating new techniques and methods are aware of the different types of sustainability concepts so that they can frame their contributions in the realm of sustainability concepts and metrics, so that there is a common basis for understanding. So that is really the goal. So it's introductory in that sense. And since we have a small group, feel free to interrupt me if you have any questions. We will also have time towards the end for questions. The outline is as follows. So we'll start with sustainability, what the current status is, and what some of the goals for at the country level, at the city level, to the extent that they have been established. So we can take a look at them. And circular economy is a big part of sustainable development. So we will spend quite a bit of time on that, along with metrics for circular economy. We will also briefly touch on environmental policy, which is a key catalyst, if you will, or enabler for sustainable development. And I would also like to conclude with some suggestions for the Carbon Zero Challenge teams to think about as they prepare for their interviews. Okay. So starting with sustainability, the current status, this is a chart that communicates what is green in color here is the comfort zone for various planetary systems. So climate change, ocean acidification, stratospheric ozone depletion, etc. There are 9 planetary systems. Each is called a system because it's an ecosystem within itself. If we take climate as an example, and the extent to which perhaps Aishwarya, you could mute all so that there is no background noise.
I'm doing that, sir.
Okay. So the extent to which the green threshold is exceeded is shown by the red. So for example, for climate change, that threshold has been, exceeded? That is, the comfort zone has been exceeded. Similarly, for biodiversity loss, the comfort zone, which is green, has been exceeded. That's why you see that in red. So this is kind of a rough indicator of the current status in terms of the different planetary systems, where they are with reference to the comfort zone. Okay. And I won't go through this in detail, but basically something that you can perhaps read later on. At the summary level, there are still very many issues that are poorly addressed, all the way from insufficient civic awareness to growing per capita consumption, etc., etc. Life cycle impacts of solutions not sufficiently well understood. And so there are a lot of opportunities that exist for addressing these issues, starting with the innovation, which is what this challenge is all about. In tackling environmental issues, civic awareness is also increasing. There are lots of startups, and the governments are eager to solve problems, but they do lack many times a sound, coordinated public policy. And that's one of the items that we see needing emphasis. And just to give you a snapshot, right, at what some of the sustainable development goals are, if you take at the USA level for America, what you see here is the list of 17 different sustainable development goals. And these goals are defined by United Nations as agency responsible for environment and climate. For example, the very first goal is end poverty. Next goal, SDG 2 is nutrition, and so on. SDG 12 is sustainable consumption, very much to do with the carbon zero challenge, right? And for each of these goals, there are the actual as of 2015, in this case, 17% is the poverty rate. You might be surprised in the US whether there is that much poverty rate, but there is. And the target for 2030 is 8%. So the actual and target at the country level. Now, similarly, if you look at for the US, SDG 7, which is modern energy services, renewable energy as a share of the total is 6.3% as of 2015. And the goal is to get to 30% by 2030. Climate change, the CO2 emissions per capita, it's 17 tons as of 2015, and less than 8 tons is the target for 2030. Now, the reason for me to show this is also to highlight the value of metrics. If you want to control something, then you need to measure that so you can manage it, right? So, the metrics for the various sustainable development goals, the metrics have been established, and countries have many countries have voluntary goals, including India, which I will also share with you the next couple of slides. Is what I'm showing clear to you? Is it coming through clear? Any questions so far? Okay. There is a very detailed report on. Can you please mute yourself? Okay. There is a detailed report, sustainable development report as of 2021. This was published by the United Nations. Some well-known authors, Jeffrey Sachs of Columbia University, and many others. This report details, for instance, if you take the case of India, for the various 17 goals, for each goal, what the goal is set by the country, voluntary goal set by the country. So for example, this is for SDG 11. which is sustainable cities and communities. I'm sorry, it's too small, so you can't see it, but the idea is really to just show you that there is a detailed report. And if you zoom into it, the Sustainable Development Goal number 11, sustainable cities and communities, one of the metrics is annual mean concentration of particulate matter of less than 2.5 microns in diameter. Now, why is this important? Well, this is a measure of pollution, and which is implications for our lung health. And as you measure it, you can keep track of whether it is becoming better or worse, and what actions need to be taken, and why it is important for, say, the Carbon Zero Challenge is teams that are aspiring to contribute to reduction of particulate matter can see, okay, this is the current value, and what is possible in terms of bringing it down. And any technologies that are developed can then be tied to goals like this. That's one of the values that you can derive from a report like this for aspiring startups, right? Now, drilling down into Chennai, India's health capital. Well, I actually didn't know it was actually called the health capital in India. The particulate matter 2.5 levels that are currently 5 times the World Health Organization standard. So it's not good. So anyway, this gives you an idea about the metrics, and also in the case of the metric for Chennai, the sources for these particulate matters are also identified. Now, why that is important is, for example, industrial sources that contributes, transportation contributes. Each of these contributes to various levels. So innovations can be prioritized based on where the contributions are pretty high. So aspiring teams can look at this and say, what can I do or we do as a team to address this particulate matter concentration, okay? Now, so we have so far talked about sustainable development and metrics associated with it, and how you can interpret it or use it. It's important to know that the economy, circular economy, is a big part of sustainable development. And also, it's a major focus for Carbon Zero Challenge. So let's spend some time on what circular economy is and how to get to circular economy. Now, this is a sort of a busy diagram, but the basic thing is, as raw materials move through various stages of manufacturing, parts manufacture, product manufacture, and so on, and then they get to the user or the consumer. Now, after the consumer consumes it, what happens? Well, they could either send it to the landfill, or from the consumer, it can be reused, or it can be remanufactured, refurbished, remanufactured, or it can be recycled. So there are various possibilities, but these possibilities will exist only if you design the product so that they can be remanufactured or recycled. So all the way from design, it's very important to pay attention to these characteristics. And there are still lots of questions to be addressed. Obviously, you want to reuse as much as possible. Recycling is the least desirable. Of course, sending it to the landfill is really the least desirable. The next least desirable is recycling, and remanufacture and reuse are better and better options. So the question is how to design for reuse, refurbishing, recycling. What are effective recycling technologies? What are life cycle impacts? What are viable business models? What are necessary government regulations, subsidies, and incentives? Because the government regulations, subsidies, and incentives do play a big role in catalyzing these various recovery flows. So it's important to study them. So it's important to study the design of the product. It's important to come up with different technologies for various recovery options. It's also important to study the government regulations, subsidies, incentives, what roles they can play. Okay. Now, at a bird's eye view level, the companies or businesses, they produce products which are then used by consumers, after which they could send it to the landfill for safe disposal, or even better, it can be sent for post-consumption value recovery, like remanufacture, recycle, and so on, and then get back into the supply chain. Now, what is the role that government can play? Well, it can provide regulations and incentives to encourage as much recovery as possible. So that's where the role of the government is. Again, this is a high-level bird's eye view. Now, to get into the metrics for circular economy, let's understand a few high-level concepts. And I have listed these high-level concepts here, and some of these you would have heard of them. Consider the entire product life cycle for costs and environmental impacts. And we'll go into what that is, okay? Consider embedded emissions. That is not only what is in your own manufacturing, but in the raw materials that you get from your suppliers. It already captures environmental impacts. So that's what we mean by embedded emissions. And so they're categorized as scope 1, 2, and 3. System view of proper allocation, system view for proper allocation of effects. When you have the same manufacturing line shared by different products, you need to have good ways of allocating the resource consumption. And the time value of money for normalizing different cash flows. As we all know, a dollar today is worth, or a rupee today is worth, when you have it in hand, compared to getting it a year later, right? That's the time value of money concept. All of these are some of the basic concepts that you need to understand as you look at developing metrics for circular economy. And through life cycle assessment method and life cycle costing method, we can get to these metrics. Now, talking about life cycle, we all know this infamous ship, right? Which hit an iceberg and sank. What is that ship? Anybody?
Titanic.
Yes, Titanic. Good. So this is an example to show that the cost that you see, the acquisition cost, is only the tip of the iceberg. There is a lot of other costs that are there, but they may be hidden unless you really look at the life cycle aspect. So we tend to focus disproportionately on the operational cost or the acquisition cost and not seriously consider these, and they could sink the product. That's really the message here. So it is important to pay attention to the entire life cycle for a product, conceptual, preliminary design, detailed design, production and construction, and then the usage of the product and disposal. These are different life cycle stages of the product. Now, bear in mind, this is the life cycle of only the product. But what is also important is the life cycle of the system. What do we mean by that? Well, the product, as it goes through design and production and usage, you need to have manufacturing lines that are ready to produce. You need to have system support, like call centers that are ready to provide support. You need to have retirement and disposal systems that can take the product and safely dispose them or reuse them and so on. So the entire system you need to consider when it comes to understanding the cost of a product or a service. So not only the life cycle of the product, but the life cycle of the entire system. Okay, that's really the message here. Now, moving on to considering embedded emissions. Well, what do we mean by embedded emissions? The direct emissions we're all quite familiar with. This is the emissions in your own manufacturing process. If you have a factory and if you have a process, these are the emissions that are in your process. That's scope 1. Scope 2 is, for example, the electricity that you purchase. Although you're not burning fuel, producing electricity, somebody else is doing it. And since you consume it, you are actually responsible for that. So that is scope 2, which is indirect emissions. Scope 3 is all the suppliers and vendors and transportation that you don't directly control, but you're buying their products. So you need to consider the emissions of the processes of your suppliers because you're buying their products. So together, scope 1, scope 2, and scope 3 are 3 types of emissions that one ought to consider in assessing the total emissions for a product or a service. Okay, and there are more details here if somebody is interested. Now, as I mentioned, the life cycle assessment methodology, it's a systematic way of calculating the emissions for a product or a service. Now, I keep saying we need to calculate the emissions for a product or a service. Can somebody say why we need to do that? Why are we interested in that? Why are we interested in computing emissions during the life cycle of a product?
So if we are planning to reduce the emissions, our production methods are not adding to it.
Right. So if you're developing a new technology, you want to see how much better it is compared to an existing technology in terms of its environmental impact. So to assess that, life cycle assessment is a systematic way. And it's, as you can see, it's pretty simple and logical. You start with goal and scope definition, get into inventory analysis, and then impact assessment and interpretation. I have a simple example to kind of go through that. I'm comparing 3 different products. An incandescent lamp, which is like the most traditional lamp, compact fluorescent lamp, CFL, and then LED lamp. And this is a 60 watt, this is 15 watts, and this is 6 watts. This is the number of lumens for the comparable amount of lumens. but the lifetimes are different. This is 1,000 hours, this is 8,500, this is 25,000 hours. Okay. Now, on what basis will we compare these three lamps when it comes to their environmental impact? Well, you certainly want to compare it based on what value it gives you, that is, what function. If you strictly compare it based on wattage, you will say, this is poor wattage. Well, but you not only have to look at wattage, but you should also look at the amount of light you get, right? So compare it based on function, which in this case is quantity of light, which is measured in lumen hours. And that's what we call as the functional unit, because it is a unit to measure the function. So on that basis, we can compare these three when we go through the life cycle assessment methodology, okay? And when we do that, per lumen hour, which is the functional unit, how much carbon dioxide is emitted, how much methane is emitted, how much nitrous oxide is emitted. Now, you can combine all these three and also see how much carbon dioxide equivalent is emitted, okay? These are all metrics, environmental impact metrics. So if you are coming up with a new technology to, say, make cement, then you want to compute the amount of carbon emissions per ton of cement that is produced with this new technology and compare it with the old technology, how much kilograms of carbon dioxide per ton of cement produced. So that's really the idea here. And so the very first step is to define the scope. By that, what we mean is, what are the inputs and what are the outputs? In this simple process, which is the lighting process, energy comes in, and there are emissions. Now, these emissions don't happen at home when you have the light, but these emissions happen as a result of the electricity that was generated and sent to your home, right? This is type scope 2 emissions. If you remember the scope 1, scope 2, scope 3, this is scope 2 emissions. So you define what the scope of your process is. Then you, for each of the inputs, you define the how much of that input is used per lumen hour. Again, these slides, they you can look at them in detail at the leisure, but the basic idea is you want to capture the inputs and the outputs, and you want to express them as per functional unit. And the reason why we do per functional unit is that is the fair basis of comparison. If you compare for incandescent lamp, now the next step is computing the life cycle impact. And then now you can compare for the incandescent lamp, for the CFL lamp, and for the LED lamp, the total global warming impact per lumen hour. And which is the least? Can someone see? Which has the lowest global warming impact per lumen hour?
Incandescent lamp.
Incandescent lamp has 1.852 and e power 0.5 exponent minus 0.5. Right?
Okay, it is minus.
Yeah.
Then
LED.
Then LED. Then LED.
LED, correct. So LED is the one that has the lowest global warming impact. Now, that's great. So this is the best technology from a global warming impact perspective. Now, will this still be true if you were to include all stages, life cycle stages of this product? Meaning, what does it take to manufacture this? What does it take to manufacture CFL? what does it take to manufacture incandescent lamp? Now, I have not done that study, but to answer truly the question of which is least in terms of global warming impact, you not only need to compare the operational usage, you also need to compare for all life cycle stages in terms of manufacturing and transportation and anything else that's involved. Did you get that point? Okay. So now what we have done is in the life cycle analysis, let's say if you're doing it in the laboratory, coming up with a new technology, step 1, step 2, step 3, step 4. That's what the life cycle assessment is. Step 1 is goal and scope definitions. Step 2 is inputs and outputs, measuring them. And step 3 is calculating the impact, that is the global warming impact, and then you can interpret it. Now, you do this for not only laboratory scale process, you need to do this for real life process. There are differences between laboratory scale and real life, all kinds of differences. So in order for any new innovation to be truly valuable compared to an existing process, you need to not only look at what you can achieve in the laboratory, but you also need to see how it will do if you were to apply that in the real life. So for example, you might have a great recycling technology to convert plastics into a different type of plastics. Now, you proved that in the laboratory. In real life, well, you have to go and collect the plastics before you can recycle it, right? Now, you need to include that also in the economic cost and the environmental cost of recycling. So that's what I mean by for the real life process. So you need to do LCA not only for laboratory process, you need to do it for real life process also. Okay. Now, of course, I would recommend this as the first step, especially for startups and student teams. Just focus on defining the goal and looking at the inputs and outputs. That will be a great start for in terms of understanding, so you can compare one technology versus another. Because these other steps, while they will provide more information, they also need more information for you to do the process. Okay. Now, some time back, I mentioned the role of environmental policy, right? Well, first of all, what is an environmental policy? It is primarily concerned with how to govern the relationship between humans and the natural environment in a mutually beneficial manner. Now, it's probably better illustrated with an example. You know, when it comes to policies, there are different types of policies. There are regulations, there are market-based instruments or incentives, there are voluntary approaches. In California, there is a mattress recycling policy that was enacted in September 2013, which basically requires mattress producers to create a statewide recycling program to collect and recycle mattresses. And not only that, the program will be funded by a visible recycling charge collected from consumers. Now, why do all this? Why should the government get involved here at all to do this? Does anybody have an answer? Any guess why the government should get involved in creating or requiring such recycling process, and also ensuring that there is funding available. Well, it's good for the environment, that is one thing, but it is also, it can lower the barrier for adoption of new technologies, making them viable and yield benefits sooner. Okay, so the question that I would have for the startup teams that are entering CZC is, what type of government policies, laws will lower the barrier for your innovation? If you are coming up with a new process to produce new renewable, new process for producing renewable energy, what type of policies will help lower the barrier for your innovation? Something for you to think about. Is the question clear here?
Yes, sir.
Good. So I have a couple of suggestions for the.
One question, Dr. Ramesh.
Yes.
I'm just trying to understand. It's good, very interesting. First time I'm hearing that there's a policy for, for taking back mattresses.
Yeah.
Now, that means, is the government actually saying that any new mattress that they make must have a possibility to, because I've not read this policy of the US government, that any mattress that you make must be able to get recycled and reused. Is that something like that is what is spelled out in the policy?
So the policy has requirements for businesses, that is the mattress manufacturers, in terms of being able to easily recycle the mattresses. The policy also requires the manufacturers to fund programs to collect and recycle them. So the manufacturer will actually add a cost charge, recycling charge, to the products that they sell, so that that fund gets collected and a program can be established to then facilitate the collection and recycling of mattresses. Eventually, it is funded by consumers and the government.
Okay. Good. I can I add one point, Dr. Ramesh, with your permission?
Please, go ahead.
I think in India, the Indian rules, I think for the benefit of our participants, and there's already, if you look at our plastics waste rules, there's something called extended producer responsibility.
Mm-hmm.
If you look at our e-waste rules in India, there is something called an extended producer responsibility.
Mm-hmm.
Now, something like that, I think the US has gone one step further to include for even items like mattresses, which is very good. But I think the word in India that is available in our regulations from the Ministry of Environment and Forest and Climate Change, as you call it, is extended producer responsibility.
Yes, that term is very familiar, is what is used here also. So there are, so the EPR rules, EPR programs and EPR regulations exist in many states within the US. So yeah, the same concept is in use here. Although I would say, in terms of actual usage and practice, Canada and Europe are quite far ahead in terms of creating those programs. But the US is catching up. But thank you for your comments.
Yeah, I think in India also the implementation is where many people have to come together. But the rules are largely in following good international trends is what I find the way the rules are evolving.
Mm-hmm, mm-hmm. In fact, that is one of the legs on which this whole circular economy has to rest on, which is the government policy, whether it is EPR programs or some other type of direct government assistance, to get things started and the economy going, circular economy going. There is a strong role that the government can play. Now, it's going to be, of course, different for different technologies, different products, and that's where there is, you can say, challenge or opportunity to analyze what type of policies will work for what type of products and technologies and services. It's a very rich area in terms of anybody wanting to either do a PhD, or I would even say start a startup that can develop those models that other people can utilize.
Yeah, that's very good actually. And with your permission, I can add one more point, Dr. Ramesh, if you permit.
Yeah, please go ahead.
In fact, I think now the rules are coming, even some basic things are getting repackaged and coming as rules, that, things like computers and all must be amenable for maintenance, so that, you can increase the life of the product, life of the device, although it is, the manufacturers would like to sell more, but as users we would like to have our product work longer by by some simple maintenance or preventive maintenance, or some replacing some components where required, rather than replace the whole product. So these things are also coming back in India, but I think there's a lot of difference between what the rules are thinking, the rule makers are thinking, and the execution side. So that struggle is there. That's my take today.
Yeah. No, thank you for sharing that. I have a couple of suggestions for the Carbon Zero Challenge teams. I've already talked about this, but just going over that again. So when you think about your new product or new technology or process, at least do think about these two first steps of the life cycle assessment. That's why I have shaded them in dark brown. Defining the goal and scope, meaning what are the inputs, what are the outputs of your process, and measuring those inputs and outputs, and comparing with, so that you can compare with an alternative process on the basis of functional unit. That is important. So doing those steps will be a big step indeed. And doing that for your laboratory scale process. If you do that, then later on the analysis can include all 4 steps, and also look at the real life process, which is where the real complexity is. But this would be a great start. And also think about what type of government policies or laws will lower the barrier for your innovation. And why that is important is, that's what people in the government would need to hear, right? How can they help you? So for them to help you, you help them by saying how they can lower the barrier for your innovations. So those are the 2 concrete things I think each team can think about. And that brings me to the end of the presentation. Any questions?
Mr. Anthony has shared 2 comments on the chat box. Like he has mentioned that
Oh.
So production closer to the need should lower the barriers, and in-country agencies of standards should be empowered to do evaluation.
I'm sorry. Can you repeat that again, or is it that is it there in the chat that I can look
There in
at?
the chat, yeah.
Oh,
Yes, yes. Chat.
oh, okay. Yeah, I see it here. Production closer to the need should lower the barriers. Yeah. So local production, local sourcing, right? I'm not able to hear. Maybe he's muted.
Mhm.
He's talking, I think, but he's muted.
I asked him to unmute.
Okay. Yeah. In-country agencies of standards should be empowered to do evaluations. In-country agencies of standards should be empowered to do evaluations. An important policy change would be to rank best practices. Okay. Thank you. You have any example that you would like to share?
Uh, Well, I would give the example of what we do, which is trainings in production of energy optimized cook stoves of solid fuels, for example. It is written into the Sustainable Development Goals, SDG 7 for energy, that this should be affordable. But who would send a $4 cook stove long distances for evaluation? The only way to make it affordable is if the evaluation is closer to the need.
Yeah, quite true. In fact, that is, that is something like that would come out when you look at the bigger picture. If you have to ship it somewhere, you're not only spending money and doing that, there is also other types of environmental impacts. So,
and for something as inexpensive, for something as inexpensive as a $4 cook stove, the profit margin may be too low to attract an entrepreneur. It needs to be produced by those in need of the stoves. That is what will make it affordable.
right, I agree.
For an entrepreneur, they can make it a fancy stove and sell it for a higher price in a more upscale market.
Mm-hmm. Mm-hmm. Yeah, that is why there is a need to look at the full life cycle, including the various costs, to see if a new technique, a new model of stove is better than an existing one, right? To be able to evaluate different alternatives.
The same is true of water treatment. There is a need to do the evaluations in country or closer to the need rather than sending the water treatment technology long distances for evaluation. That will encourage small scale production. There is a drive to make production large scale so as to accomplish so as to meet the quotas for the 2030 goals. And this leaves the small scale producer behind.
Mm-hmm. Yeah, good point. Thank you. Are there any other questions?
I think
Right.
due to the morning hours, we have less participants today because it's also raining here heavily. So
I see.
that's so sad. Well, do any of you have any other questions? Okay. So probably we can just there's no other questions, I'll briefly again explain about the carbon CZC 2022 procedure. The results can be expected by end of next week, so you can expect the results by then, and the shortlisted participants would be getting the template from our end. Anya, do you have any questions, sir? So I'll just continue. So the shortlisted contestants participants will be getting the template from our end. And based on the 3 topics that we covered, the budget and project planning, the customer discovery part, and then today's sustainable metrics and policy part. So based on, so you would need these background, you need to understand these topics to prepare your presentation. And the interviews would be towards the end of November and beginning of December mostly. Again, the theme wise, we will be calling them separately and you'll be intimated separately. The schedules would be sent to you. And it is an online session. And after the interview thing, the shortlisted participants from there will be called for a bootcamp session that would happen in mid to end of December. So you can expect sometime in mid-December. It would be a 2 to 3 day camp where you have to come to IIT Madras in person. So this is the itinerary for a Carbon Zero Challenge. And so this is the itinerary. Yes, sir. Mr. Sarun Kumar and Citizen Center. So he has asked you a question. I'm working on an idea to divert spent coffee grounds to make some personal care products. I would like to calculate the impact of the idea. How do I calculate the same?
Yeah, so you would start with defining the various inputs that go into your agricultural process. You're saying divert spent coffee grounds. Okay, so I would start with defining the process by which you collect and to where you're going to send it. We would need to get access certain databases that can give us information about the amount of energy that would need to be spent on converting this. So, basically you need to specify the process by which you're going to do this. Then for each step in the process, we can look at the energy and emissions. That's how we would do it. And then there is a LCA software, and many of them are quite sophisticated in terms of the amount of information that they have. So you could possibly use one of the LCA software applications like GABI, or SEMA Pro, or Sustainable Minds. But they don't cover everything, but that'll be a good place to start. Okay.
So do we have any more questions for Dr. Ramesh Srinivasan?
All right, thank you.
Yeah, thank you, sir. It's such a sustainability, the circular economy part, and it's such a complex topic. And I think you explained it pure in your simple words, and I think it came across really well. So it is. So thank you for your time, and thank you for this session, sir. Thank you.
Yeah, thank you.
Excellent session, by so people are acknowledging it as well. It's well explained. Yeah. Thank you, sir.
Thank you.
Thank you.
Yeah, thank you. Yeah.
Have a good
Bye-bye.
evening,
Yeah.
and good
You
day
too.
to the rest of you.